Okay, do we have the packets out, or are we ready to go?
So the first part, yes. Ready to go.
Now we're on page 3.
Now we're ready to go.
Okay, so we are about to start looking at more expressions, equations, and functions, which really should not be a big surprise, because that's pretty much everything we've been doing this year. Our new topic are rational expressions, equations, and functions. Raise your hand if you can remind me what a rational number is.
It's like a fraction that stops. Or it doesn't stop, but you know what it is.
Just at the beginning. If you looked at it as a decimal, it would terminate, it would repeat, but rational numbers are fractions. This whole unit is about fractions. However, it's even better than that. They're not just fractions with numbers, they're fractions with variables all over them. Okay, hold on a moment. Where did... Okay, no, hold on one moment. I'm not fine. No, here they are. Okay, we are on page 3, and we need to kind of define these things, see what these things look like, and then see how to start working with them. A rational expression is just a fraction where the numerator and denominator are polynomials. A rational expression is a fraction where the numerator and denominator are polynomials. Rational expression, a fraction where the numerator and denominator are polynomials. Not just numbers, but polynomials. For example, maybe something like x plus 2 over x squared minus 2x plus 3. Or maybe x cubed minus 4x plus 1 over x squared minus 1. Or maybe even just the simple polynomial 1 up top over x minus 1. Hold on to that for right now. Yes, we could do some long division, but there are some other ways we will deal with simplifying these things. Will actually be a lot easier than long division. Do we get what this is? Not how to do anything with it, but what a rational expression looks like? Variables in the top, variables in the bottom. So rational equation. What can we do with equations? Solve them. We're going to get numbers. They will equal something. We will solve them. We'll get number answers. I think I just want to say, in parentheses, to kind of sort of define this. Rational equation can be solved, and we will get number answers. So, for example, maybe something like x plus 2 over x squared minus 2x plus 3 equals 1 over x minus 1. That's a rational equation. The goal is to find the x that if you plug into the left will give you the same thing as if you plug into the right. I promise it's nowhere near as bad as it actually sounds. We're going to look at that stuff, though, starting next week. This week we'll just kind of deal with the expressions. So what's the third thing? What can we do with functions? Things that we can graph. Rational functions can be graphed. So what must they have, like in the formula? Y equals, or what's the other option? F of x equals. Things like f of x equals x plus 2 over x squared minus 2x plus 3, or things like y equals 1 over x minus 1. Are rational functions. We will look at graphing those middle of next week. Actually, the graphs of these are going to look rather different than any other graph we've dealt with so far this year, but we'll save those for next week. So today and tomorrow, we're going to look at simplifying rational expressions and then operations with them, adding them, subtracting them, multiplying, dividing them. Throughout everything that we do, we're always going to keep coming back to how do we work with just regular fractions? How do we simplify regular fractions? How do we multiply, divide, add, subtract regular fractions? Sharpen pencil. And we're actually going to be using some very similar ideas to work with our more complicated looking rational expressions. So before we start every little section, we're going to do some problem with just regular looking fractions, remind ourselves how those work, and then see how we can kind of extend those ideas. First example. So first we have to talk about simplifying these things, and I want to look at the fraction 6/8. Obviously you know it's 3/4, but why can we simplify that to 3/4? Divide by 2. The idea is, if I ask you to simplify 6/8, well, 6 is really 3 times 2, and 8 is really 4 times 2. There's a reason I'm doing this. What am I allowed to do with that fraction? Cancel what? Cancel the 2's. There's a 2 on the top, there's a 2 on the bottom. I can cancel them, and I'm going to get 3/4. I canceled a common factor that they had. That is how I'm going to deal with simplifying these rational expressions as well. I'm going to look for some common factors that I can cancel. Let's take a look at the problem in the box. 20 plus 40x over 20x. I need to first, well, actually, if we go back to our 6/8 problem, I rewrote everything as multiplication, so I was able to cancel things. I need to rewrite these things as multiplication problems. Well, the way we do that is by factor. The first step I'm going to do with any of these problems, step number 1, is to factor the numerator and denominator. Step number 1, factor the numerator and denominator. Remember, there are many different types of factoring. There's GCF stuff, there's difference in two squares, there's multiply to the last, add to the middle. There's the box or the x. If I just say factor 20 plus 40x, how would we do that? What should you always think about first? GCF. Alan, what is the GCF for 20 plus 40x? You can do better than 10. 20. We're going to take out a 20. Joey, what's left when we take out a 20? 1 plus 2x. The bottom, there's nothing we can do with that. I'm just going to leave it. The top is now the multiplication problem, 20 times 1 plus 2x. The bottom is the multiplication problem, 20 times x. What did I do over here when I had those multiplication problems with something that was the same on the top and bottom? Canceled them. Well, what do you have the same on the top and the bottom here? The 20. Step number 2 is I am going to cancel any common factors. Cancel any common factors. There's a 20 on the top, there's a 20 on the bottom. I can cancel those. I'm going to get 1 plus 2x over x. And that's as far as I'm allowed to go. It might be tempting to want to cancel those x's, but we're only allowed to cancel factors, parts of a multiplication problem. If you're not believing this, you don't have to copy this down. But let's say I have the problem 2 plus 5 over 5. Isn't that the fraction 7/5? Can I just cancel the 5s and make it a 2? Not at all. For a similar reason, you're not allowed to just cancel those x's there. Your final answer is 1 plus 2x over x. Make sense so far? Really, the only way this gets tougher is if the factoring gets a little more involved. That's it. So as long as we can factor, we can simplify these things. I think we know how to factor. I hope we know how to factor. On to page 4. Let's look at letter A on the top. 4x plus 20 over 3x plus 15. Whenever we factor, we should always start by thinking GCF. Alex, is there a GCF up top? 4. We're going to take out a 4. David, if we do that, what's left when we take out a 4? X plus 5. Trevor, what can we do on the bottom? Take out a 3. Molly, if we do that, what's left? X plus 5. So I have 4 times x plus 5 on the top, 3 times x plus 5 on the bottom. Ethan, what could I do? Yeah, there's an x plus 5 factor on the top. There's an x plus 5 factor on the bottom. We can cancel those factors. Your answer actually has no x's in it at all. It's just 4/3, which is actually kind of interesting, which is really saying that original 4x plus 20 over 3x plus 15 thing, if you plug in any number for the x, plug in 10, plug in 20, plug in -5, you'll get a number on the top, a number on the bottom. It will always be a fraction that simplifies to 4/3. That's all that's kind of saying. Letter B. Solomon, what can we do on the top? Take out an x. What's left?
X minus 5.
Good. And what's the GCF on the bottom? 1, so we can't do anything with that. But how else can we factor x squared minus 25? It's our difference of squares pattern. It kind of sounds to me like you're trying to solve an equation. We're just factoring here. It's our difference of squares pattern. We're going to get x plus 5, x minus 5. Yes, maybe? Well, here's the point. If I factor it into x plus 5, x minus 5, do you now see something that can get canceled? Sure, we couldn't have done that in the beginning. So, Walter, what's the next step going to be? What's your answer? There we go. Factor and cancel. That's it. Letter C. Are there GCFs anywhere? Martina's shaking her head. Yeah, there aren't any. But you know how to factor those things. Multiply to the last number, add to the middle number. So go do that. Factor the top, factor the bottom. I believe if you do it properly, there should be some common factor. Go do it. Alex, how does the top get factored? X plus 5, x plus 8. Good. Trevor, how about the denominator? I'm not totally sold on that. I think we have to switch the signs. As you had it, we would have gotten positive 2x in the middle, and I want negative. And this is what I should be doing. X plus 5, x minus 7. So, Joey, now what? Answer is? And can you cancel the x's? No, you cannot. Only factors, only parts of multiplication problems. They're GCFs in D. What are you going to do? Okay, which means box might be helpful, or an x might be helpful, or any of those things. See what you can do. Again, if you do it properly, there will be something in common that can get canceled. Take a moment. What you can do in D. I really don't think there are too many combinations here. It's not like I gave you 18 or 24 or something like that. 4 or 3, not too bad. Molly, have you factored the top?
Yeah, 2x minus 1 plus 4.
If I put that in the box, I get negative 1 plus 8x. Yeah, that's the 7x that I want. Walter, do you have the bottom?
Yeah, I got
2x minus 1, and what was that?
x minus 1. That's a plus 1.
I'm thinking x minus 3, because we've got to multiply to that 3 at the end, and then we'll get our negative 6x minus 1x. Yeah, that should work. Do you see what's going on?
Yeah, I just wrote it wrong.
Ah, okay. So Abid, now what?
You can cancel out the 2x minus 1.
What's your answer?
X plus 4 over x minus 2.
Do we get how to simplify? Like, really not a big deal? As long as you can factor, you can simplify these things. Multiplication and division. Let's look at multiplying. And before we multiply any of these rational expressions, let's just deal with multiplying rational numbers, multiplying regular fractions. 1/6 times 2/7. How do we multiply fractions? So what do you mean by just multiply? Yep, multiply across. So you didn't say anything about a common denominator, right? No, we don't do that for multiplying. Multiply the top, we're going to get 2. Multiply the bottom, we're going to get 42. Is that your answer? Now what? Now simplify, we can divide by 2, and we'll get 1 over 21. When we multiply, we just multiply the numerators, multiply the denominators, and then cancel. Let's look at these with rational expressions. On the next page. So, yes.
Can you cross simplify with fractions?
We can. We will deal with that in a little bit. We need to multiply and then simplify. Well, here's the deal, though. This is going to be absolutely horrible to FOIL the top, FOIL the bottom, then somehow try factoring that. That's not going to be the way to go. Rather than doing that, the first thing I'm going to do is go through and factor every numerator and every denominator. I promise that will make the multiplication so much easier. Step number 1 is going to be factor all numerators and denominators. So I'd like you to take a moment, maybe more than a moment, and factor all 4 of those parts. Actually, not the first denominator, because you can't do anything there. But all the other 3 pieces. Take a moment and factor. I actually see 3 totally different factoring patterns we'll use here. See what you can do. Just factor and then stop. I really think only one of these pieces is a little tricky, that first numerator. Other than that, though, I don't think they should be too big of a deal. Actually, even that one, there aren't too many possibilities. Martina, do you have that first numerator factored?
No.
The 2x squared plus 7x plus 3 part?
Yeah.
What do you have?
2x plus 1 and then x plus 3.
I think that's going to work. 2x plus 1, x plus 3, that gives me 6x plus 1x, 7x. Yep, that works. Can't do anything at all with that first denominator, so I'll just leave that as x minus 4, although I think I will stick some parentheses around it. You'll see why in a moment. Ellen, how about that second numerator? The x squared minus 16 part? Sure it is. Difference of two squares, so x plus 4, x minus 4. Michael, do you have the denominator?
No, I'm just going to...
Trevor, do you have the denominator? X plus 5, x plus 3. First step is a whole lot of factoring. Right, David? Add up, please. Thank you. Any questions with what we've done so far? Step number 2. It's time to multiply these things together. Although to multiply, all I'm going to do is just stick all my numerator factors together and stick all my denominator factors together. We can't, I don't want to do that just yet. I will let you do that in a moment. Let me show you how this continues to work, and then we'll hold on to that for a moment. Step number 2, I'm going to go and actually do the multiplication step, which again, as far as I'm concerned, is just going to mean stick all the factors together in one big fraction, which actually, Ellen, is why we're allowed to do that cross-simplify piece. We are going to stick all the factors together in one fraction. Which means, in the top, when I multiply, I'm going to get 2x plus 1 times x plus 3 times x plus 4 times x minus 4 over x minus 4 times x plus 5 times x plus 3. That's what I mean by multiply. I do not mean FOIL. That's going to make it more complicated than it needs to be. Just stick all the factors together. But what can I now do? I'm looking for a word that starts with an S. Simplify. Not that one. Simplify, which really just means cancel any common factors. Are we writing?
Yeah.
Okay, are we canceling? Mm-hmm. Good, because you're going to tell me in a moment what I can cancel.
All right.
So what can I cancel, Mike?
So you can cancel x plus 3 on the top and bottom.
Okay.
And you can cancel x minus 4
Okay.
on the bottom. And that's going to leave you 2x plus 1 and then x plus 4, and then over x plus 5.
And that's our final answer.
You want to multiply this?
No, we're just, because we kind of want this as factored as possible. That counts. That works. Honestly, multiplying is really just a whole lot of simplifying, which is really just a whole lot of factoring. What Alan and Solomon were asking earlier about cross-simplifying things. This x minus 4, this x minus 4, sure, you could just cancel them out. The reason we're allowed to is because really we're just sticking them all together in one big fraction and canceling. If you go straight from here to this final answer, I'm okay with that. As long as you're only canceling something from the top with something from the bottom. Perfectly fine. Well, try the example on the bottom. I think the one on the bottom is actually quite a bit easier than what was in the box. Do some factoring, multiply, and then cancel. And then we'll look at dividing. Actually, I think only 2 of those pieces have factoring that you can deal with. I think the other 2 you're just going to leave, although maybe stick parentheses around them. David, first numerator, what does that become? The a squared minus 4. How can we factor that thing? Perfect, a plus 2, a minus 2. It's our difference of 2 squares over there. Bottom I'm just going to leave as a plus 1. Second numerator I'm just going to leave as a plus 1. Walter, how about that second denominator? What can we do? A times a plus 2. Good. I am going to go and do the multiplication step. If you feel like you can skip it and just start canceling, I'm okay with that. But I am going to multiply. Up top, I'm going to get a plus 2, a minus 2, a plus 1. On the bottom, I'll stick those pieces together. The a by itself usually just kind of looks better if you put it out front, mostly so you don't lose it in the middle of something. So I'm going to say a times a plus 1 times a plus 2. So, Alex, what are we going to get for a final answer? A minus 2 over a. Are there any questions on multiplying? Nod your head if you're kind of with me. Not really. If you can factor, you can kind of deal with these things. Division. By the way, anyone have an idea why I would want to talk about multiplying and dividing before we do addition and subtraction? That's kind of a weird order to go in. What's easier to do with fractions? Multiply or divide them, or add or subtract them? Why? Aha. To add or subtract, we need a common denominator. That's a little more involved. We're going to save that for tomorrow. Multiplying and dividing, though, not as big of a deal. Although I guess now we have to talk about dividing. So we're going to start with just the 1/4 divided by 3/7. How do we divide fractions? Alan? Good. We're never actually going to divide fractions. We're always going to turn a division problem into a multiplication problem. Well, we already know how to multiply. That's not a big deal. We're going to get, in this first problem, 1/4 times 7/3. We're going to get 7/12. To divide, we're never really going to divide. Instead, we're going to multiply by the reciprocal of the second fraction. We are going to multiply by the reciprocal of the second fraction. And really, multiplying is just a whole lot of factoring and then canceling. hopefully it will stop turning yellow. We'll see. In letter A, I don't actually want to do that problem. Instead, I want to do a squared plus 2a minus 15 over a squared minus 16 times. What happened?
It turned yellow.
Oh, there's something wrong with the chords. I don't know. I don't really want to do the problem written. I want to do that problem instead, that multiplication problem. You know how to do this. Go do it. Factor and cancel. Second numerator, yes. What should you always think about first? So do always think about that first. I sort of think that not much will cancel here, but that's okay.
Wait, when we're doing this, you already have the a plus 1. Why do you already have the a plus 1?
Because I can't factor a plus 1. That's as simplified as that piece is going to get.
Oh, so first we factor that, then...
Right.
So we don't really have to factor the 2 on the top.
No, but this one you can factor something on the top. There's a GCF you could deal with. The 3, right. Ethan, what did your first numerator become? Good. A plus 5 times a minus 3. Molly, how about your first denominator? A squared minus 16.
A plus 4.
A plus 4. A minus 4. Alex, how about the second numerator? Okay. Good. So you could skip the next step. I'm not going to. I am going to go and just kind of multiply stuff, so put everything together in one big fraction. So 3 times a plus 5 times a minus 3 times a minus 4. Again, I want to put the 3 out front, mostly just so I don't lose it. Joey, now what? That's gone. That's gone. That's the best I can do. That's okay. We're just going to get 3 times a plus 5, a minus 3 on the top. And on the bottom, a plus 4, a plus 1. Questions? We look like we might have a question on the side. Or we forgot to write something. Okay. The next one. Obviously, we need to turn it into a multiplication problem, but does anyone see anything kind of strange looking in letter B? Aha. Okay. To be able to really do any sort of like factoring work, we really need our things in standard form. So what I'm going to do, first of all, when I turn it into a multiplication problem, I think I need to change the order of this. Anything else that's a problem? Yeah, and actually we'll deal with that in a moment. But do you see anything else that's not in order? Not in standard form? 1 minus x. Make it a multiplication problem and put all the pieces in standard form. Then we'll deal with that other issue that Martina just commented about the negative. And I think I do want to add a little note in here saying that really before we do any of this stuff, we need to put all polynomials in standard form. Put all polynomials in standard form. Foil. So here's the deal. We can't just like get rid of a negative. Divide, but that's kind of like getting rid of it. What's like the big word we've been doing with everything here? We're going to factor something out. We're going to factor out a GCF. Here's kind of the weird new thing. Up here, what can I say my GCF is that I can factor out? That's what I'm going to do. Before we do this, I do want to write one little note over here. We want each leading term, the thing with the highest power, the thing out front, to be positive. So if it's not, what we're going to do is we're going to go and we're going to factor out a negative 1 from each of those pieces. So bullet point over here, we want each leading term to be positive. If it's not, we are going to go and we are going to factor out a negative 1. Which is exactly what I see us needing to do in the first numerator and second denominator. So first numerator will become negative 1 times in parentheses x squared plus x minus 2. And I'll deal with that more in a moment. First denominator is still just x plus 3. Second numerator, I'll factor this more in a moment. I'll just leave it as x squared minus 9 for now. Trevor, what can I do in that second denominator now with that negative x plus 1? One more time. Good. Take out a negative 1, and we're left with x minus 1. I feel like you should be able to probably deal with the rest of this. I see some more factoring we can do. X squared plus x minus 2, go factor that. Factor your x squared minus 9. See how far you can get with this. We have one more page and we'll be set for today. Might even have some time to start the homework. But let's finish this first. Oh, go factor. Do you have the same thing on the top and the bottom?
Yeah.
Sure. Is it part of a multiplication problem?
Yeah.
Sure. So we can cancel it. Solomon, do you have a final answer for this one? Yeah, so the negative 1's cancel. X plus 3 cancels. The x minus 1 cancels. There's nothing left in the denominator, so everything's left in the numerator. We don't have to say over 1. We could just say x plus 2 times x minus 3, like Solomon said. David, I'll give you a moment to make some make some change? I assume you're somewhere else. Okay. One thing before we move on to the next page, only because you're going to see something like this in the homework. This isn't in your packet. Oh, that's kind of a horrible color. Okay, well, it's not supposed to be a yellow screen, and it was green paper, but besides that, if I have something like this, x plus 3 over x minus 3. Okay, sure, the top is x plus 3 squared, but that's not so useful. So both Martina and Molly are saying just x plus 3. Yeah. This x plus 3 can cancel with how many x plus 3s from the top? Only one. If I had two x plus 3s on the bottom, that could cancel both of them, but I don't. I'm just going to get x plus 3. Something like that's going to show up somewhere in the homework. Just going to be on the lookout for that. I don't think that's a big deal. But just realize you can only cancel one factor with one factor, not like one factor from the bottom with two from the top or something like that. Last piece for today. We need to talk about these horrible-looking things called complex fractions. A complex fraction is a fraction where both the numerator and denominator are fractions themselves, like a half over 3/4. I promise this is nowhere near as bad as it looks. It's just division. Isn't this original problem really just saying a half divided by 3/4? Right?
Yeah.
Which is really just saying what? Alan?
So it's
1/2 times 4/3. I don't think so. Yep, which will give us 4 over 6, which simplifies to 2/3. These are going to look horrible, but realize it's just a division problem, which is just a multiplication problem, which later on with like the more complicated things just means a lot of factoring and canceling. It's just a different way of writing it. But I do want to look at the next example with you because the pieces are a little different than things we've dealt with so far. I'm going to start this one by writing it like a normal looking division problem. If you feel like you can skip this step and go straight to the multiplication, okay. But I've seen too often people kind of put things in the wrong place, something that should be the numerator ends up in the denominator. So I always do the first division, then multiplication, then go from there. I'm now going to write this as m to the third over 3n times 9n squared over negative m to the fourth. Yeah, the negative could go on the top or the bottom or even out front. I think when I actually multiply, maybe I'll just stick that out front or something. Do not overthink. What is m cubed times 9n squared? Do not overthink. M cubed, 9n squared, and usually we put the number out front. So I'm just going to say 9, m cubed, n squared. We're just going to stick them all together. On the bottom, 3n times negative m to the fourth. Say that one more time. Let's multiply those numbers. So 3 times negative 1 will give us a negative 3 out front. And I'll just change the order to make things match the top. It doesn't really matter. Negative 3, m to the fourth, n. More or less. I feel like this looks like a law of exponents problem, like back from September. Divide. What did we get with 9 over negative 3? Negative 3. If you want the negative, could just go out front. That also works. Or I could stick it with the 3. Tell me about the m's. M where? In the denominator. Tell me about the n's. 1 on the top. N squared over n. I feel like if you can deal with this one, you can probably handle anything in the homework tonight. This is about as tough as they're going to get. If you go straight to multiplication, that's okay. I just worry that if you do, you might end up putting things in the wrong place. So I always show it just to be safe. But if you feel like you can skip it and things are correct, that's okay with me. Really? If you say so. It's some good factoring practice. I don't actually think in the homework there are too many that will use like the box or the X or something like that. I think most of them are a little bit easier factoring. I do. That's coming.
Like in the real world.
That's coming.
Right?
Yes, it takes a little too much right now to kind of explain because we need a couple more tools first. But at the end of the chapter is all sorts of very realistic like word problems that we're going to use this stuff
so I
for.
was gonna say, like, you know, like parabolas and stuff.
Once we finish this, flip to 7.5 to look at some of the types of problems we can use it for. Abid, were you able to deal with 3x squared minus 4x minus 4?
Yeah.
How did you factor that? Couldn't hear. One more time. 3x plus 2, x minus 2. I think that's good. Negative 6x plus 2x. Yeah, that's the negative 4x that I wanted. Solomon, the 7 one. 7x squared minus 19x plus 10. Did you factor that?
Yes.
Into what?
I got 7x minus 5 and an x minus 2.
That could be right. Let's see. Negative 5x minus 14x. Yeah, that's the negative 19x that I want. So I'm going to go and multiply. Negative 1 times x minus 4 times 7x minus 5 times x minus 2 over 5 times 3x plus 2 times x minus 2 times x minus 4, I think. Maybe. Question? Problem?
No.
What didn't you do?
Oh, it's just like the end.
That problem?
What part? Never mind. Never mind. The x minus 4s will cancel. The x minus 2s will cancel. Negative 1 times 7x minus 5 over 5 times 3x plus 2. Questions?
I don't know. Is it negative 5 or is it?
Yeah, you could move the negative to the bottom if you want. That's okay.
In the inside, is it 7x minus 5 or 7x plus 5?
Mine. They both need to be negative because they have to multiply to positive 10 and add to it.
The negative 1.
Whoa. Hold on. We only took the negative 1 out of the 4 minus x piece.
Okay, so what's
Yes.
minus 5?
I was talking about they're going to go online, they're going to hear you keep on asking these questions. They're going to, God,
Have you figured out what's going on?
Wait, it's recording.
You never act. No, it only picks up my voice and not your.
Oh no, I didn't realize it was recording.
It's fine. It's all good. David.
I literally had that.
That's fine.
Yeah, I mean, I guess to be fully simplified, the final answer should be like as factored as possible. So if we distributed it, it wouldn't necessarily be as factored as possible. I would take that for a final answer. If you said negative 7x plus 5 over 5 times 3x plus 2, I'd be okay with that.
Oh, that's what I did. That's what I should.
That would also be okay.
That's why I said plus.
One final comment about the homework. This is going to sound like really obvious, but every year I have someone like not do this and not get credit for the homework. If in the homework you just do a lot of things like this, I'm getting a new piece of paper out. Okay, backing up. In the homework, I think I need to see a whole lot of factoring, right? If you do things like this, x squared plus 2x over x squared plus 3x plus 4, and just say, oh, cancel the x squareds, cancel the x's, you completely missed the point of today, and I can't give you any credit for the homework. Make sense? You're going to do a lot of factoring. So I think we're going to stop here.
So instead of being able to cancel out x squared,
We have to factor.
so it's
Factor
3x
and
squared.
cancel.
Don't cancel.
Factor. Factor and cancel. So the homework. The beginning of the homework is just the simplifying stuff, not the multiplying, not dividing. They should actually go pretty quickly. I actually think if we have some time to start working, we may be able to get all of 1 through 12 taken care of in the next 8 minutes. Those are going to go quick.
Let's do this right.
And then the rest is just the multiplying and dividing, which again is a lot of factoring and stuff. Tomorrow we'll take care of adding and subtracting. So let's start working on some of the homework. I'll get the lights on in a moment. I'm going to stop this thing. Maybe. There should be. Even though I recorded things, I think this is a lot easier to learn if you're here in person. And we're going to need this for the entire unit. And if you miss today, you're kind of out of luck.